Hello, 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 hello. I think we're live. I think we are. Hello, welcome. Step right in. Let me get today's project. Hey, Rusty Russ. Rusty Russ is the best. Hello, hello. Just a moment, I'm just going to remove this address label. On the box of today's project. Hey, Russ. Russ has been a member for 6 months. Thank you, Russ. Good morning. I hope everything looks all right, sounds all right. It's been a while since I've done a stream. Since I've done anything, I've been rather busy. So, let a few more people get in. This is here's a pile of parts from the last PS5 I worked on. I did not do a video on it. I probably should have, but it just, anyway, it was a rather complicated repair and it took me a long time. That and a lot of stuff going on, but lightning damage. All those parts were destroyed. Lots of the power supply parts. Many pieces of electronics died that day. So today we have another project. This should be in here, a PS5 motherboard sent in by a viewer of the channel. I think his name was Milton. And we think this is a bad, he deduced this is a bad south bridge. And he has sent me a south bridge to install. So hopefully he sent the right one. And hopefully that is the problem. So this may be a simple repair. Let me see what model this south bridge is. Too much glare. Too much glare on it there. It is a 61 GG. I hope that is correct. But this gentleman, he's a viewer of the channel. He had emailed me looking for some assistance with this one. And apparently the backstory is that it belonged to a friend of his, and it had quit, and it was sitting off to the side, and he visited the friend and said, hey, can I have that? Since it's not doing anything, I think he was just going to toss it. So that's how it became in Milton's possession. And then he efforted repairing it. Tried swapping out the power supply, and that was not the issue, apparently. He deduced that it needed a south bridge, and he did not want to attempt swapping the south bridge. And I've had it sitting on the shelf here for about probably a month because of work. Haven't had much of a chance to do anything. So I told him I would either do a video or a live stream of it. There's Clear Slug. Oh, there's a capacitor rolling around. He did say he had replaced one of these caps, but that's just kind of, was just floating in there. Starbucks gift cards. That's okay. That wasn't necessary. I'm not really a coffee drinker. My wife is, though. So she'll probably appreciate those. Hang on to this packaging. Hopefully I'll need it to send it back to him. Hello, Sarah. Yes, my daughter is in the chat. Oh, looks like you pulled the cover off of the APU there. So that seal is missing. I'm wondering if he's got a way of sealing that back up. He's going to need to. That liquid metal is going to go everywhere. So this is a EDM 010. This is the original. He mentioned something about, he emailed me, I think he had just started removing random capacitors. I guess to check them. So we're going to have to give this, oh, I see he's replaced that 220 with an electrolytic there. And with this, with a conventional leaded type. We might replace that. We might just replace that. Samsung RAM. So, oh, we're missing, oh, I see. That capacitor must have come from right here. I think he tried to replace this capacitor right here, which is on the 5-volt rail, yeah. And it was not soldered very well. And it popped off. I have to make sure that is the right capacitor for that location. It looks like it. Anyway, I am kind of curious. There's another one that's been replaced there. It's a little bit, I don't know if you can see in the camera, it's a little bit taller than the original. I think that's an original there, that with the blue. But these red ones, I think he decided to replace them. And they're a little bit taller than the originals. And they should work if there's enough clearance, though. If the cover will go back on here, that may be an issue. Yeah, that could be an issue. So maybe we'll replace, if we can get it working, maybe we'll swap those out with some from a donor. Hello, who all's coming in the door here? There's Andy. Hello. Andy, Russ, Chlorslug, the usual suspects are here. Welcome, welcome. We are working on a PS5 board. I only have the board. That's all I've got. I'm kind of curious as to how much current this thing draws. Let's see. You can see my power supply here, I think. Let's give it 12 volts. But the person who shipped it to me seems to think the south bridge is dead. I have not done anything to the board yet. I'll make sure I get this polarity right. Let me get that cord out of the way. Okay, how much current draw do we get? Pretty well sits at 9 or 10 milliamps. Okay. What do we have? 5 volts? Do we have 5 volts? We do indeed. So, I'm guessing we've got 3.3. Where's our 3.3? No 3.3? 1.15. Do we have a short on the 3.3? Because there is nothing there. Okay, let me kill the supply. Let's go to resistance. 3.3. No, we're 700 ohms on 3.3. So we had no voltage. Well, we had 1.15, so our fuse isn't blown. The fuse has to be good because we're getting 1 voltage. We're getting the 1.15. 3.3 is just sitting there. How about 2.0. Yeah, we've got that. I think this is like a 1.8 or something, is it? Having to try to remember. So we have some voltages coming out of this RT5126. Let me look at that chip under the microscope. If I can remember how to, let's see. Let's go to microscope full if we can. Well, this chip does not seem to have been replaced. A whole lot of scratches. There's been a lot of probing going on in this area. Oh, the owner of the board is messaging me just a moment. I told him I was probably going to do it today, and I need to tell him streaming right now. Okay. Oh, there's Milton. There's Milton. I think this is your board. I'm guessing. Unless there's a different Milton. We're looking around this dialogue chip because we have... Why is that so dark? Why is that so... I'm sorry. Give me a moment. I know what's happened here. I don't know if I've mentioned this to you before, but I got a new TV, and the remote for that new TV, whenever I adjust volume or something, I don't know, my microscope camera picks up, the infrared signal and interprets it as being reduce the exposure, and it's really irritating. Just a moment. And I don't realize it's done it. I haven't used this camera in a while. But I know that's what it's done. No. Down. Here we go. It happens to give the commands to this camera for exposure. Okay. Yeah, we're way down there. So if I set this back to 0. Hey, look there. It's like magic. Let's get rid of the menu. I'm sorry about the darkness. I didn't realize it. I had not looked over there. So we're looking much better now, I think. Your eyes? What's wrong with your eyes? Get your eyes fixed. All right, now back. Meanwhile, I've got the 1.15. I've got the 1.98 or 2 volts, whatever. That's the one that goes to the south bridge, this capacitor right here. 3.3 right there. Well, I'm very curious why there's no 3.3. And if there's no 3.3, you have no voltage on your NOR chip down here. Nothing. There's not a whole lot going to happen when that happens. What happened to the side of the south bridge? I'm worried about all these nicks right through here. Some damage to the solder mask. Why don't we have the 3.3? Let me turn off the power supply. I want to see if we have a short on this capacitor right here. No, we don't. 10 k ohms. And usually if that south bridge has died, you'll have a short right there, because that goes to the south bridge. But we're just missing 3.3 out of this chip. Do we just have a bad dialogue chip? Can't be that easy, can it? Is there anything on the other side of the board there? I don't think there is. Let me see, let me see. I think there's just a couple of... I just want to make sure there's nothing knocked off. What the heck is that? What is that? Oh, it's a solder ball. That should not be laying there. Okay. Just looking to make sure there's nothing knocked off in this area. So we don't have 3.3. I mean, the only time I've ever seen 3.3 be missing is when it was shorted to ground. But I measured, I'll check again, I measured like 700 ohms there. Yeah, and this coil is good, isn't it? Yeah, coil is good. Coil is good. Well, should we just replace that DA9065? Because I can't think of any reason for that to not be there just right from the start. Those are generally there. The 1.15, the 3.3, the 2 volts, which comes from another chip, and there's a 1.8 somewhere around here. And those are generally just there from the beginning. I need to work on my tweezers, looks like. They've lived a long life. Let me see if I have a DA9065. Look at the flux under the south bridge. Andy, that's got nothing to do with... I'm sorry, maybe I'm part of the... And maybe I'm missing some previous conversation here. Yeah, that's good. The south bridge, unless it's short, is not going to keep that 3.3 from being there. DA9065 or RT5126. I'll take either one of them. What do I have that's new? I'm pretty sure I've got one of them. Here we go. Here's RT. Here's some RT5126s. That should do. I've got quite a few of those. Got quite a few of those. Let me switch back. I don't remember buying that many of those. What are these? 5127. I've got a common drawer for both of them. I've got some used ones in here. What are these? There's a Dialog. What is that? 9065. Okay. I choose you, Pikachu. All right. So I'll remember how it's oriented. I haven't been waking up my soldering iron. I'm going to have to turn on this ceiling fan. It's getting warm in here. Just a moment. What are we discussing over here? Sean? Hello. Oh, they do fit? Okay. Okay. Yeah, these, my flux is going everywhere. I can't say I've ever seen these things, you know, just fail on their own without some help. They're pretty darn reliable. Everybody see all right? Oh, you can't see the microscope. Professional streamer here. Professional. Probably turn the heat up a little. Okay. Looks pretty good. Where did I put that chip? Nope. Keep going. All right. Come on now. Just about there. We're a little crooked, I think. Yeah, we're a little crooked. And this is the point where he should have left it alone. Referring to myself, I should have left it alone. Okay, I'll leave that alone. Flux kind of ran everywhere. Alright. I'm not really trying to clean that too well. I probably should. Just don't like throwing alcohol on it when it's blazing hot. I'll let it cool off a little. That should work. All right, what do we think? Are we going to get 12 volts now? Not 12 volts. 3.3. Clean up some flux that's spilled over there before I get it on my leads. Power is off. cooled off enough. We let it cool off just a little. What are we discussing over here? Andy, yeah, he is a negative Nancy. Don't you have a radio, a stereo to repair, Andy? Huh? Hello, Sean. Roy. It's fixed, you think? Oh, the stereo? You fixed it? I missed the end of the stream. I'm sorry. I had to hop in the shower, and I missed the end of the stream. Okay. Do we have 3.3 here? I'm going to apply 12 volts. No, we do not. We do not have 3.3. We still have the 1.15. Interesting. No 3.3. What are we missing? Are we missing an enable line? We do have the 2 volts. That should not be a problem. Yeah, this is acting just like it was earlier. Resistance. 12K there. Just going to see if there's any shorts around this chip. There was no short on 3.3. So it's missing some sort of an enable signal or something. $700 ohms to ground on it. Should not be an issue. I'm trying to remember where some of these signals are. What was that? Oops. 57 ohms. 57 ohms on that. It's not, no. Figure out what that signal is. This pin right here, which is pin 1, 2, 3, 4. It's 57 ohms to ground. What is pin 4 of our friendly DA9065? One moment. I'm going to consult the schematics. Don't tell Sony, though. As soon as I find it. It's 5. The DA9065. Just a moment. All right. Can I share this? Is it going to be a major issue? Here we are. Okay. Pin 4. Pin 4. One, two. I did say it was 4, didn't I? 1, 2, 3, 4. That shows to be the 1.15. Well, that was there. All right, let's get another board. Let me get a known good. Here we go. Here it is. This is a known good 010 board. I want to see what the resistance is. I have another capacitor that's fallen off. Okay, I'll put that over there. Let me set that board out of the way. So, yeah, 1.8 k ohms, 2 k ohms on that 1.15. Let me confirm. Pin 4 here. 1, 2, 3, 4 is that same point. It is. So maybe we should be looking in that area. Yeah, about 2 k ohms is what I get on that 1.15 rail. So maybe it is a bad south bridge. Let me set this. Maybe it is a bad south bridge because we are getting a 50 something ohm reading. Let's look at the back of the south bridge on these coils leading into that south bridge. Two k ohms, 2 k ohms, 700 ohms up here, 1.8. All right, this is going to have the battery voltage on it, so I'll leave that one alone. All right, where does that 1.15 come in here? 1.8. All right, what gives here? Let me make sure I still have my low reading. No. So did I have voltage going in the board when I was checking that? I was going to say, 'cause it magically disappeared. No, there it is, 57 ohms. 57 ohms. But I don't see it. I'm going to have to look and see where that goes. But I'm pretty sure it does go into the south bridge somewhere. It has to somewhere. I'm going to cheat and look at the schematic. SSPG1. Okay, where do you go? Where do you go? Yeah. Right into the south bridge. It may not go through a SSB 1.15 volt core. It goes in there, it just, maybe it's not on one of these big inductors. I have to look. Well, let's see. I can figure out which pin it goes in, but it's got to be here somewhere. Let me make sure everything is. We will find it. I'd like to see it. So it's not there. It's not on that inductor. Oh, that's that battery. 2 ohms. That's that. There's battery voltage there, so that's not accurate. I thought it went through one of these coils. What is this? 0, what about this side? There's our 57 ohms. So it's on this big pad right here. Yep. 57 ohms. That's not right. So Milton, I think you did get it right. You got a bad south bridge. I think you got it right. Hello. Sloth Tech, hello. Oh, okay, that's right. You had a bad power chip. One channel was bad. So, okay, so you found a bad chip. Good deal. I missed that part. I just saw you had the big, big power, that big flat IC out. Okay, we need to replace the south bridge and reinstall some capacitors, looks like. One there at least. Okay, so this DA9065 is just fine. I'll add it back to my parts. It's just fine. Let me get my board heater out here, or preheater. See if we can get it swapped out. Looks like Andy has gone live again. According to the notification on my phone. Let's see. Need to remember to take that battery off. So it does not blow up in my face. I'd never had one blow up, but I don't want to tempt fate either. That's the best way I found to take those batteries out with tweezers to plug. Because if I've tried using like the plastic tool from the side, and it always breaks the little, contacts around the edge. The plastic snaps, always. But if I just take it out like that, it comes out no problem. They don't break anything. Let me get my temperature probe here. We run around this side. Kind of get as close as I can to this chip. This is how I do it. There's no good way of attaching this probe. So I just kind of wedge it in a nearby hole. Take a clothespin and lock it in place. You just slide it that way a little, maybe. All right. Start giving it some heat. Let me turn this down to, I start at 120 C. And we'll start warming it up. I just kind of slowly warm the board up. I'll take this nozzle off the hot air. What are we talking about? What are we discussing here? If you replace the RAM and you still got the error, then you probably have a connection problem under the edge of the APU, I'm afraid. That's what's likely. I mean, you can make sure all the little resistors and stuff are in place around that RAM, but what you probably should do is just take that RAM off and then start making like diode measurements, like on the data and address lines, and see if you have all the readings. Because if you're missing one, then you might be able to push down on the edge of the APU and make it come and go, that kind of a thing. But it sounds like you may have that kind of issue. You love that T8280 fan? Yeah, I need to replace it, I guess, but it has not bothered me enough to buy another fan and replace it. Yeah, it's irritating, but it works. I am going to start heating this board at 120. The temperature on the heater on the display is set to 120. Basically, I'm going to get the board up to about 100, 110 reading here. So I'll probably get to about 200 on the preheater and let the board get up to around 100, 110, and then I'll use 400 C from above, 400 Celsius heat from above, and add some flux. But I kind of like to do it slowly. I'm going to bump up my the preheater up to like 137. I just slowly step it up. At my age, why bother to change it? Why are you suggesting I can't hear it? I can hear it just fine. Milton, I think it came to the conclusion probably because of some resistance readings underneath the south bridge. Would be a guess. Let's see. Step it on up a little bit higher. She's getting warm, nice and toasty. Let's see. I have a power supply I need to fix here also. We may do that on stream. This one failed. One of the PS5s I got in to fix was dead on arrival, and it was just a power supply. So I just swapped it and put this to the side and said, we'll do that later in a stream or something. ADP 400FR. So maybe we can fix that. If we can get through this. We're getting warmer. Target temp. Now I usually go, I'll get to 100, between 100 and 110. I'll get the board temp, and then I'll use hot air from above. That's just me. PS2? No, this is a PS5. We're just ramping this voltage up. Yeah, You're going to have to come up with a way of sealing the top of this APU. Some people use clear varnish on it. You can use like electrical tape, you know, but you're still going to need that foam barrier. I don't know. I may have one around here. Don't know if you have a plan for that. Let me add some. Go ahead and add a little flux to this. Get my solder wick cleaned up and ready to go. We're getting there. Okay, 150. That's getting up there pretty good. But yeah, a lot of the things. I mean, you kind of figure out what works for you. All right, I'm at 200 here on the hot air. I'm on the preheater. Let that warm up a little bit more and get over 100. Let me get. Here's our new chip, ready to go. Let me open the package on it. Come on. I like 210, 211. Luckily, there's nothing on this model. There's nothing nearby the south bridge to worry about melting. If we get to about 170, this thing should come right off. Let's see if she's ready. Almost. Come on. There we go. I'm going to turn off the heater. There we go. Put some good old leaded solder. I'm going to turn this fan on just to blow the fumes out of my face. Okay, did I miss any? Looks like the solder mask survived rather well. Oh, U-break I fixed so they couldn't do it. There's Optimized Logic Repair. Welcome. This is looking pretty good. I'm just looking at these scratches over around there. I don't think any of the traces are cut though. I don't think they are. I'm not sure about that one. It looks like that's ground going in there. Let me check. Just for the heck of it, before I put this chip back on. We're in continuity mode. Where was that ground that looked compromised? Here? Let's see. Is this ground? That is ground. I think it's just the solder mask is nicked there. I'm hoping. But if this thing doesn't work, we'll have to take a closer look at those scratches. I see one that I missed up here. Right up there in that corner. There's always one. There we go. Yeah. I think we're pretty good now. All right. Let's pop this chip on here. Turn it the right way, maybe. Man, this thing is... Look at that corner. They beat this thing up. Hopefully it's still good. She's got some scratches on her, though. Looks like they took a grinder to it. All right, I think we're lined up pretty well. Dot lined up with the arrow. All right. Let me get that out of the way of the temperature. Where is my little bent needle thing? What are we talking about in chat? Oh, the U-break I fix. Yeah. I don't know that I have one in my town. I'm sure there's some nearby, but All right. I set it on there and I'm letting it kind of acclimate itself, you might say, warm up a little from the board. Give it a few seconds to, I'm trying not to thermally shock the thing. And this is probably reballed with lead free. Because if I had reballed it, would be leaded, it would, you know, it'd sit in place a little quicker than it's going to. All right. Again, though, it gets to about 170 or so, it should be sitting down. I'm going to try to nudge it without knocking it across the board or burning my fingers. Contemplating using my other hand to do it. Should be close. Let me try it this way. See if I can nudge it a little. Oh yeah. I think we're good. I think we're good. We'll find out. I'll take it off when it cools off, and we'll look at it from the side. Let's see. I usually try to take this thing off the preheater to let it cool down a little quicker, because the preheater holds a good bit of heat. So I will set this off in my lap and burn my little fingers. Probably. Yikes, it's hot. And just let it sit there. And I'll shove this preheater out of the way. Maybe it's not so loud anymore for you guys. Do some more cleanup on this flux. But that is interesting. The south bridge, it seems, was not allowing that 3.3 to come up because of a low reading on the 1.15. I don't think I've seen that one. Yeah, I need to spray alcohol and scrub it. I was trying not to thermally shock it there. But I will have to clean it up. That entire area. That's warm. What's right? Oh, Russ. Wow, Russ, thank you. A nano fix? Well, push. Thank you. Thanks, Russ. Russ is being very generous today. Thank you. That's very, very nice of you. Very unexpected as well. Yeah, you got a good line up there, didn't you? You did. All right, let's see. That's surprising. Probably going to sizzle like crazy. Let me get that off the surface. And let me see if I can get it out from under the south bridge. It's still hot, but it's not like it was. Yeah, it's still warm, but I can tolerate holding it. Let's look at these the balls under this south bridge from the side to see if it looks halfway decent. Yeah. I think we're good. Let me look at this side. What about this side? Maybe. I think we might be good. Let it cool off just a little bit more. I'll check resistance on that 1.15. Keeping in mind it is still a little, board is still a little warm. Well, we're over 1.5 k-ohms. That's a big improvement. Still kind of toasty. Let this fan kind of blow across it. I don't usually put a fan on these things. I usually just kind of, you know, I'm a little more patient. And I just let them kind of slowly cool down on their own. Rusty Russ is the best. I did say it. Yes, I did. Of course, he did. He also put it in the text. He actually put it in chat. But thanks, Russ. That's very kind of you to give memberships like that. I need to. Did I bump my? Here we go. Try to get where we can see that power supply. Yeah, she's cooled off enough. Let's get the old bench supply hooked back up. And I'm going to want to check to see if I've got my 3.3. But we might be able to tell quicker if that current goes up to 300 milliamps, then we will know our answer. All right, what do we think? Is it going to work? Let's see. I'm going to get another 3.3 volt rail. And let's give it 12 volts. No. Denied. We have our 1.15. We do not have our 3.3. That's disappointing. We still have our 2. Are we getting... What is going on with this thing? What is going on with this thing? No, wait a minute, wait. I need a sanity check for a moment here. There's 5 volts. 1.15. There's the 2. Oh, wait a second. Is our 32 kilohertz oscillator running? That is very concerning, though. Why don't... Let me make sure I don't have a short on a 3.3. Oh, my computer went to sleep over here. Everything went dark. Wake up. Uh-oh, now it's buffering like crazy. What happened? Sorry, my stream seems to be... No, it's not just you, it's mine. What is going on? Is it back? I'm getting a warning now that I got... So I've got low data rate. Although we're having some technical difficulties with the stream for some reason. YouTube is complaining it's not getting enough throughput from me. But OBS says everything is just perfect. So somebody is lying. Oh, we're good now, Roy? Okay. 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 The warning finally went away in the studio window for YouTube. That was weird. That was weird. Good now. Okay. We're back. I thought I was going to have to end the stream and restart it because something weird was happening there. But yeah, OBS says everything's great. So somewhere between here and YouTube, it was not so good. So far we've had an epic failure. We replaced that south bridge. Resistances look great. Look absolutely great. But we are missing that 3.3 volt rail. It's not shorted. That's very low current draw. I'm trying to remember if I've seen this exact problem. Give me a moment, let me crank up the scope. And these test pads right here beside that 9065. A couple of these are I2C data, which I figured out before. Nothing there. No voltage there, no voltage there. Why do I have a feeling there's a component knocked off somewhere? Oh, well, turn the power back on. Let me check this 32 kilohertz oscillator. Which I don't know that would prevent the 3.3 from coming up. But I'll check it. Because it's actually powered from 3.3. So it's probably not going to be there. So we got to figure out still why this 3.3 is not there. We need to keep in mind that we've got some capacitors knocked off that may or may not be related to this issue. All right, let me get a good view here. Switch my scope to AC coupling. I don't think there's anything there because we don't have 3.3, and it needs that 3.3 to run. So that's why we're dead. Yeah, there's nothing there. The 3.3 isn't there. But if I put the battery back in it, in theory that oscillator should run then. I'll turn it, I'm sorry, where you can see the scope here, but there's nothing there. I'm not connected, but let me snap the battery back in the board and see if that oscillator starts running. The current draw did not change when I snapped that battery in there. Nothing. Nothing. Absolutely nothing. Now, off. It's weird. Oh, so you can see it. It's not like the current goes up and comes back down in a hurry. It doesn't. It never goes up. I want to make sure. I don't think we're getting 3.3 and it's shutting down or anything. It's just we're never getting it at all. Let me turn the supply off and back on. Ah, it did try to come up, didn't it? Yeah, it does try to come up. Interesting. It tries to come up and shuts down. It doesn't seem to be shorted. So it's like 700 ohms or something. No shorts there. Nah, didn't think so. I was checking onto the Wi-Fi Bluetooth module. But I mean, that's a separate 3.3 volt rail, a separate 1.8 volt rail. Totally separate. It's got its own supply. Is there something knocked off? I know we have a capacitor missing, but it's not really right on top of this area. There's a capacitor missing on the 5 volts over here. I mean, it needs to be there, but I don't think that's preventing this from starting. Let me get that out of the way. Our battery is dead. Our 2032 is dead. So is that being shorted? Let me pop that battery out. I mean, it doesn't need this battery to work. That's just to back up the clock. That battery's just dead. We don't have a short there though, do we? If I go across these terminals in resistance mode, 6.7K. That may explain why the clock didn't start running over when I put the battery in there, because the battery is no good. Let me find another battery. But that 3.3 should be there anyway, because it powers the darn thing. I'm just curious here. 3 volts. All right, let me pop this one in there. Make sure it didn't get loaded down when I did that. No, it did load it a little, 2.94. So now, I don't think it's going to make any difference in the current. No. But in theory, we should have 3 volts on that diode. Where'd it go? Right here. No? Where is it? Hmm? What? This battery voltage should be showing up here. Okay. Is something lying to me here? Nothing. So, three volts there, 0.36 there, and 0 there. What is going on? Let me pop this battery out. I mean, it only goes to the south bridge. Let's do some resistance checks. Two ohms. Well, that's just fine and dandy, isn't it? 2 ohms. 2.7 ohms. That's a tad low for that CR23-2 to drive. So, do I see that low resistance at the south bridge? Do I see it? I believe it should be here. Yeah, there it is. So that's why it's shutting down. That's exactly why it's shutting down. There's a short on the 3.3 volt rail, but it's isolated by a diode, which is why I can't see it when I'm measuring with my meter in resistance mode. So like on this side, this is the 3.3 volt rail on the left from the DA9065. There's our 700 ohms. But on this side, going into the south bridge, we have 2.4 ohms. So that's why there is a short. We just can't see it because they're isolated by a diode. Of course, if I had checked right here, I would have seen it. So, is there a solder blob? Is it just a bad south? But this is identical. What are the chances of it being of having the exact same short on the 3.3 volt rail with a different south bridge. What are the chances of that? Yeah, I'm sure there was a nice spike there, but that's going to be the issue. It's but that only goes into the south bridge. Now there's going to be a tiny cap up in here. Well, there's actually several caps, isn't there? It's there's one there, which I've never seen it fail, and there's a small one there. So I guess we could inject right there. But I mean, it just about has to be the south bridge. Doesn't have to be. It's just something. I don't really believe in coincidences too much here. I mean, we would be very lucky if one of those capacitors had shortage right there. Let me just get tell you what we'll do. We'll just kind of, let me get my other supply set up over here. It's set for 1 volt at 3 amps. That's tame enough, I think. What if I just drop some alcohol on those? I see like 3 caps right there. There's like, let me get everything in the picture. So it should be, yeah, right here. Make sure it's in the picture. Inductor, cap, via into the other side of the board to the south bridge. So if we just put some alcohol there, I don't want to open up this coil, so I'm going to tap it on this coil. Let me turn it on, actually. It'd probably work a whole lot better if I turned it on. That's 1 volt, 3 amps. Is that capacitor getting hot right there? Look at that. I don't believe it. I think I should believe it. Yep. I think we found it. I've never seen that one fail because it has 3 volts on it. Well, I guess any of them can fail. So yeah, let's get rid of that that capacitor right there. And I probably should replace it. So our south bridge was probably good too. And that's something I got to remember. I'd forgotten that there was a diode. There's a diode there, so it isolates you from that south bridge. Let's get some, maybe a little fresh solder on this, and maybe she'll come off somewhat willingly. I need to put my nozzle back on my hot air. Yeah, that is the right one. I don't want to grab the wrong one. There we go. I'll set it to the side. So, is our 2 ohm short gone now? I'll get back in focus. Right here. There, look at that. Come on. It's fluctuating, maybe because something's very, very hot. But I think our short's gone. Maybe I'll let it cool off just a little, and we'll give it 12 volts. That was a weird one. Never seen that cap fail. While it is cooling off, I might just see. I need to look up the value of that cap. It's not too bad. What are we chatting about in chat? The dial? No, I haven't any problems with my preheater. Oh, I'm sorry. You're talking about the you're talking about the load. No, I haven't had any problems with it. Which I did make me some new leads for this thing. I haven't showed you. The other one had like, I think it was 14 gauge wire I was using. I think this is what is this number? Number 10 I've gone to, and I put a plug right on it to go right in the power supply. So anyway, a little less loss across the leads next time we work on a supply. Yeah, I think we're fine. Let's give this board 12 volts and see what happens, shall we? So I have not put the battery back in it yet. And that battery is dead because of that short. It drained that battery. Let me get my leads out of the way. Getting that other channel so I don't get them mixed up and grab the wrong one. I'm making a mess with liquid metal. Turn that off. All right. Trying to make sure you can see the power supply. Lead polarization is right. Let's give it 12 volts. And we're still dead. Well, that's kind of, that checks out. Yeah, we're still dead. Do we have that 3.3 volt now? That's what I want to know. Do we have it now? Turn it on. Yes, we do have 3.3. We're still dead, but we have 3.3. So baby steps there. So what else is wrong with this thing? Or what other problem have I caused? So 1.15, 1.3. Is our 32 kilohertz oscillator running? I'm going to have the scope to make sure I get on the right contacts there. I think we're running. Make sure you can see it. We are running now, 32 kilohertz. Okay, that's encouraging. That's running. The current draw is still low. Do we have corrupt firmware? That's going to be our next stop, I'm afraid. I want to see if this 25 megahertz is running also. That's on the top side of the board right here. Or whatever you want to call it, the APU side. Right in here. Yep. Yeah, I think she's running as well. 24.999. Pretty close. So the oscillators are running. So that's a good start. I keep turning that camera around. Let me turn you back to the scope here. Sorry for the whip pans on that, but I want to look at these data lines. Go into DC. Get on. I want to look at the data lines going into this south bridge. I want to see if the south bridge is like trying to access it, trying to load its data. That's what I want to know. Power is off right now. Let me get on this resistor right here. I'll give it 12 volts. I need to get a little more vertical sensitivity, I believe. Because I think this is set to 10x. Yeah. I think we have can't tell. I thought I saw a burst of data there. No. Let me speed this sweep up. Yeah, I can do a one shot if I need to. I'm not really seeing the data I'd like to see. Let me try another pin here. No. No, all these other pins are staying low. Oh, there's some, what is that data? Or is that the clock? There's quite a bit of something transpiring there, isn't there? Get my trigger up here where we can actually see it. There's something going on there. Let's see if we can do a single shot on it. Nope. Triggered a little too fast. If I slow it down a little. Single shot it. No. Not seeing anything there. You do get something there. I'm sorry about the glare on that. I wonder if I can move this scope a little. There we go. Maybe get rid of that glare. Oh, then it's my lights. I'm sorry. Which pin? Are we missing a component there? Is that a resistor that's missing on pin 3? Or is it a capacitor? Looks like something's been knocked off there, doesn't it? Now, let me look at another, let me look at another board here. What is this behind me? It's a 20, but it's going to be the same. Are we missing something there? Yeah, we're missing a resistor. Let me move some stuff around. Let me get the 12 volts off the board before I blow something else up. Set you aside carefully. I don't want to knock any more components off. All right, this is a 20, which has the same type. Yeah, same layout. So, yeah, we're missing a resistor right there. What is the value of that resistor? 4.7 ohms. Sorry, get my meter in the shot. 4.7K. So we're missing a 4.7K on pin 3. Oh wait, there's a resistor on the bottom too. Was that one missing? 4.7K. Were both of them missing? Let me turn the board the right way. There we go. Yeah, we're missing 2 resistors. Yeah, 2 4.7K resistors. Well, that might do it. That might do it. 4.7K. Let me find my resistor book. What size is that? Other than tiny. Is that a 0402? Just a guess. Let's see if it's an 0402. What do we think? 0402? All right. Let me turn off this heater down here and get rid of that wine. All righty. Maybe a little flux. See if we can tin these pads a little. Or at least tin one side of it. Trying to decide whether to put it on with hot air or just, you know what I'm saying, just secure it down with some solder on each end. With the soldering iron and not heat up the area again. I don't think that's down at all. Not at all. Nope, no it wasn't. I saw it move. I'm going to end up using hot air probably, but I thought I would try it. No apparent reason, just yeah. Is that one good? That looks a little better. Let me get that alcohol out from under that south ridge. All right, 4.7K. Let me put my resistors back up before I lose them forever. Which I need to turn off if I'm streaming, apparently. Is it back? Are we working? Yeah, my computer's going to sleep. You know, it's version of that's ridiculous. Let me go into power management here and turn that off. And all it's doing is putting the screen to sleep. Let me turn this off. Never do that. I don't remember ever doing that before. Are we back? Or are we still lagging like crazy? I won't continue until we get back fully. But that's what it is. It's when my it goes to put the screen to sleep, which I don't recall it doing that in the past. But I've turned that off now, so it will not turn off the screens. It will not try to shut down my displays. So we won't continue until it's back up and working. Oh, I see it just updated. Come on. Come on. Come on. Come back to me, stream. Solid now? Yeah, it's my computer was putting my displays to sleep, and when that happened, it makes no sense to me that it would interrupt the streaming. But I've turned that off, so it will not try to turn off the screens anymore. It's a power saving feature. Feature, air quotes. All right, we're better now. Yeah, I'm hoping it won't. I've never had that problem here. Let me hit refresh. We're back again. We're back. Come on. All right. That's a lot of latency. All right, now the warning has gone away. YouTube was giving me a warning about not enough data. I'm going to hit refresh on my window again. We're much better now. Are we... Can we continue? Are we working well? It says excellent now in the window. That is weird. Okay. Are we back fully? Are we working now? It looks like it is on my end. All right, I'm sorry. I'm sorry, guys. I'm not sure. Okay, look, I think we're back. It's my computer shutting down the displays. And I don't know, I've never seen it do that. Oh, Cat Eye. Gifted a membership. Thank you, Cat Eye. I'm back. All right, I'm sorry. I stopped. My flux is making a mess here. Yeah, like I said, I think it was my computer turning off the displays. I don't know what that has to do with the streaming, but you know, if I didn't move the mouse for 30 minutes, it was set to turn the displays off, and that makes no sense to me as to why that would interrupt with the streaming. All right, so we're about to give power to this board if the stream will hold together. If the stream will hold together long enough. You can see my power supply. I think we're back. We're back. That's weird. All right, we're going to give this board 12 volts and hope we see 300 milliamps over here. Are we back? Everybody back in? Thank you. Thank you, Steve. All right. 12 volts. Polarity is right. There we go, 300 milliamps, and back down. That looked like a winner. Excellent. I think we're there. Let's do it again. 300 milliamps, and we come back down, and in a timely manner. That looks correct. Took us an hour to get there, or was it, almost 2 hours. It's working. It's working. So, are you still here, Milton? It's your board. It It looks like it's going to be working. David, this is not in Windows, this is Linux. So, yeah. This is Ubuntu Linux that I'm streaming from and that I do most of my work in. I do have a Windows computer over here behind me, you know, for running pieces of software. So, did Milton leave? Did we? That was the owner of the board. I may have lost him in one of my outages there. I'm sorry about that. So yeah, I think we're working. We do have a few capacitors to install. Make sure, yeah. We're pretty consistent. We need to put a battery back in it. Which one of these batteries was one of these is dead and needs to go in the garbage. So yeah, the whole problem was just a shorted capacitor, which, let's face it, that has taken down many PS5s. 3 volts and 0.12. All right, you go in the garbage, then you go in the board. And yeah, 3.06. That time you notice the voltage didn't drop when I popped it in there. You know, the last time I did it, it dropped way down because it was loaded. Now there's a resistor and a diode in series with that battery. You know, right in that little area. So that's why it didn't just go to 0. I'm not sure what the value of that resistor is. It's probably like a K ohm or something. Tiny little resistor and diode. So anyway, but that's what drained that battery. All right, so our south bridge is good now. I mean, and this other south bridge is probably fine. The problem was that capacitor. Oh, I need to replace that capacitor, don't I? I need to replace that capacitor. I don't have to replace the capacitor, but I probably should. Let me find a donor. Oh, there's Milton. It was, I don't know if the main problem was a shorted capacitor underneath the south bridge. That was the original problem. It was killing the 3.3 volt rail going into the south bridge. And that's why when I was checking it, you know, over here on the DA9065, it wasn't there. You'd see it come up and go down because there was a short, but it was isolated by a diode. So when you checked right here on the 3.3 volt rail, you didn't see it. With a meter, it wouldn't show it. But the supply saw it when you applied the voltage. So I removed that capacitor, and now it's working. But it was missing 2 resistors around this NOR chip right here that somehow had gotten knocked off. If I can get it back in focus. This is a 4.7K, and that's a 4.7K. And they were both knocked off the board somehow. So that's why even after it got the 3.3 volt rail back up, it still did not work because those resistors were knocked off. And now we are going to try to get a capacitor to put back in place. Oh, I gotta let my dog outside. I'm not sure if you can hear that. The dog is very unhappy that she is locked in the bedroom and it's a beautiful day outside. What am I doing? Wrong side of the board. So we're going to steal a capacitor from right. I think it should be that one right there. Yep, that one. Let me go let Hazel out, and we'll pull that off the board, and I might get me something to drink on. Get just a moment. Talk amongst yourselves. Let me let Hazel out. Come on. come on. Well, it's not as sunny as I thought it was out there, but it is still nice out there. Get something to drink. All right. Are we still streaming? Has the stream died again? Oh, hell. Hello, Martin Ramirez. Thank you for becoming a member. Thank you. I'm going back reading the chat. I'm sorry. Yeah, there was a resistor knocked off. Actually, two resistors knocked off. So I need to remove this capacitor right here, and I'll transfer it over. Yeah, just thinking. I need to remember to maybe pop that battery out when I go to put it in the other board, because there is 3 volts from the battery sitting there. And I probably shouldn't short it out. Not going to hurt anything because it's, 3 volts from a watch battery, but still. Okay, let me set this capacitor down and not lose it. I'm going to pop the battery out of it since I'm going to be soldering on that circuit. Yep, right there. Might add a little bit of solder to those pads. Find my capacitor that I managed not to knock off the desk. Alright, that's settled right in place. All right, and there was some capacitors that were knocked off that I was going to put back. And are these identical? 390s at 6.3. Yeah, they're a little tall, but if you think they'll still clear the cover, let me look at this other board over here. And you put that battery back in, don't I? Yeah, let me pop the battery back in it before I forget it. All right, capacitors. Like right down here in this corner. Yep, 391 or 390. And that's 6 volts. And this one up here, that's also at 390 at 6.3. And that's a 220, which, I mean, that'll work. I can replace it if you want me to with a donor. Let's get these other ones back on there. What are we talking about? Mr. Bacon. Well, welcome, Mr. Bacon. I'm sorry. Yeah, we had a shorted cap behind the south bridge and some missing resistors. Well, the initial fault's going to be a shorted cap, which I thought was going to be a bad south bridge, and I replaced the south bridge, but it was not. It got blamed, and it was innocent. Now I'm just replacing some capacitors that aren't. Oh, the legs are still there for that cap. For one of them. Let's get those cleaned off of there. See if we can get a cap installed on here pretty good. Yeah, it should be. Did I get it? That's why I like this big tip. When you need some heat on these ground pads, it's got you. Just trying to put a little more solder on there. Let's see. Now, which way does this thing go? I don't want to put it the wrong way around. I'm gonna, all right, so, yeah. Got it. I was comparing it to another board here, so it goes like so. Let's see if we can get some heat in here. Turn the board around and do the same thing on the other side. Get it in focus, maybe. I managed to get it a little crooked. I hate when I do that. Maybe I'll touch up the other side again. Is that? That does not look like it's down. I don't think it is. That does not look down. Let me look at it from the side. Well, maybe it is down. Nah, it's not as down as I'd like for it to be, though. Not as down as I would like for it to be. Maybe I need to take it back off and get rid of some of that solder under there. I'd love for it to lay flat on the board. Is there still there's not still a component in that pile of mess there, is there? You know, the lead, I mean. We'll get rid of some of that. And nothing stuck to the bottom of the capacitor. No, that looks pretty good. Oh wait, there's some junk under this capacitor. I don't know if that was holding us up or not. Let's clean it really well. Is there anything in the way? Any reason it would not sit down properly? I don't really see anything. Let me clean it really well. Huh, that pad's been tore up, hasn't it? You can tell that. Let me lower the scope down a little, get a little better focus. Yeah, that pad has been pulled up. See where it's kind of damaged there? It's moving a little. A little too much. Let's try this again. May have taken a little too much solder off that side. All right, that certainly felt better that time. Let's look at it from the side. It's a little bit better. It's still up in the air a little. I'm going to leave it alone though before I end up damaging the capacitor or something. Clean this up a little. Get rid of this. I got some solder on these components over here. There we go. It's a little bit better. Okay. So we got another one to do the same thing with. Over here. And we do have a leg left there also. Uh, Alrighty, we got that off of there. Looks like plenty of solder there. Now, which way does this one turn? Which way does it turn? Which way, which way? The red marking to the right. So, like that. Anything on the bottom of this one I need to get rid of. Doesn't look like it. Maybe some flux on the bottom of it. Let me. Okay. All right. Do it again. Try to get it straight. Oh, crooked. Okay. All right, is that one down flat? Not really. Is that because the leads are bent on it? I think the leads were bent out on it a little bit. I'll see if it'll sit down for me. It's still up in the air. I don't like that. I want it to sit flat. Why won't it sit flat? I'll just take this stupid thing back off. What's the problem here? Just too much solder under it? I mean, she looks pretty flat there. All right, what if I just remove the solder and then go back and run it under it? Some rather large copper planes there. All right, which way did this turn? It goes like that. I mean, it looks like it should sit right down nice and flat. This should not be the hardest part of this repair, but here we are. Hey, she's down. I think I just had too much solder under it. I think I had just too much solder under there and it had nowhere to go. All right, so that's the two that we had missing. Well, they were knocked off. They fell off. You know, one of them fell off when I took the board out of the bag, and the other one fell off when I was, I guess, turning the board over. Okay. Should I replace this other one right here? Does that one need to go? I'll heat it from the bottom. I might have done that. I'm not sure what's on the other side of the board there. Should I replace this one? I think I will. Well, I know I have a donor. Can I get to When I get to I have a donor board here I can pull one off of. It's just, it's awful close to the other one there. It's going to make it kind of hard. As far as heating from the other side, there's some chips there. I don't know that that tip is going to go in there without melting something. I'll give it a try. What I may have to do is just move the scope out of the way so I can come in from straight above. Don't know if this is going to work or not. And these things have really good ground plane to them. I just can't get in there. Yikes. Getting hot. Surprise, surprise. Yeah, I don't know if I can heat it from the other side. I mean, I can, but I'm going to be throwing heat right on this, the IC that, you know, switches the 5 volts out the USB port, possibly damaging that. This is a donor board. You can see it had, you see the lightning damage on it. See the Ethernet port? Yeah. She took a pretty good hit. I was looking for another one. Is there another one that's easier to get to? Yeah, what about these over here? These are the same, and they're turned where they're a whole lot easier to get to. 220s. Yeah, the same markings. Let's do that. Let's work smarter, not harder. How about that? It's a whole lot easier to get to. There's nothing on the other side of the board there too. Let me add a little fresh solder to it. And maybe we'll try to heat it from the other side of the board and get it off kind of cleanly if we could. Let me lower my scope a little. Having trouble getting things in focus. All right, let's see if that'll come off. If I heat from the bottom. Hopefully not burn my desk. Come on. Yeah, I don't see this ground side. I don't see it flowing yet. Requires some patience. Yeah, the other side is very liquid. I'm hoping this thing doesn't blow up in my face. There's that side. Ground is still holding though. There it goes. What are we talking about in chat? All right, we're going to replace this one. We're going to try to anyway. We're going to have that same issue of it's in a tight space there though. Let me clean this off and put some good leaded solder on there. Might make things a little bit easier. Because this is probably the lead-free factory stuff. Oh, there's a leg still there. Well, get rid of that. So, go away, alcohol. A little there, a little there. Put some of this Kester on here. Just a little if I could. Yeah. Now, get our capacitor, which it's turned the same way as the other. Is there anything on the bottom of this thing in the way? Nope. Well, some solder on there. Let's get rid of that. And that. Because I want it to lay kind of flat. I can shift it to the right, you know, by as much as I can to give me some room. Oh, and I still got it crooked, didn't I? Still managed to get it crooked. Turn this where I can see it. Now, can I get in there? I can from the side. Let me put a little solder on my iron. It's got some on it. And get in there. It's crooked. It's a little bit crooked. Just a second. Yeah, I could change the tip to a smaller tip. May have to do that. This is just kind of better for getting some heat in there, though. There we go. I think we got it that time. I think. Where'd it go? Where'd it go? I don't like how it's rocking around. I mean, electrically, it's connected. I am going to burn my finger. All right, how's it look from the side? Oh, not bad. Not bad. I think we're at the point of leave it alone before you destroy it. Okay, the cleanup. I think this is the last thing we needed to do to this. I can't really, well, do we want to try to boot it? I'll have to find a chassis. There's no liquid metal on the top of the APU. I mean, I think she'll turn on. All right. I know it has flux under it. All right, I think she's there though. Okay. All right. Yeah, there's no protective. I could put a little bit of liquid metal on there. I was just reading everybody's chat. Should we try to turn this thing on? That is the question. I'll have to get some liquid metal. I am kind of curious to see if it works. The barrier is missing. And if liquid metal escapes out of there, I can put some electrical tape around that. We still need that sponge barrier. Where is my electrical tape? I used to. Not something I use too much in PS5 repairs. But I know I own some. I don't have any PTM 7950. I had thoughts of getting some. Have not looked into how much it costs. I've got just conventional stuff like Arctic Silver or whatever, but I know that's not good enough. So I'd rather not try that. I do have some liquid metal, I think, laying around. But I would like to not short the APU at this time. I haven't made any readings on the APU. Might do that. I'm assuming the APU was fine. All of its problems were way before the APU. About 200 ohms, 300. I'll take that. This is about 1.2K. Yep. Let's see. Should have about, this is about 0.2 of an ohm, 0.36. What's my resistance of my leads? 0.06. And this one should be like 4 ohms or so. Ooh, 9. That seems kind of high. Over here, 28, 3.8. Well, nothing shorted. How about the RAM? 1.35. 25 ohms, that's probably fine because it is Samsung RAM. You'll get a higher reading on the others. But if I can't find that black electrical tape, I can't really test this. Well, I could put, you know, solder mask. I hate to do that though. Unless, you know, the owner was okay with it. I've done it before, it worked just fine. I was digging around for some black electrical tape. I know I used to own some. Not in there. Oh, yeah, clear nail polish works. I wonder how long it will run if I just put some, you know, conventional stuff on there. Let me find a chassis. I need a 1000 series chassis. It'd be nice if it was one that was open. What is this right here? That's a 1200 series. let me find 1,000. What is this right here? That's a slim that I need to replace the RAM in at some point. 1015B, that's a digital. It'd still work though, it's the same series. What was wrong with this one? This one has bad SSD chips. And I'm afraid it's the ones that have the, you know, per console information that you can't replace. Let's see. How long would it last? I don't know. Hang on. Let's get this. Oh, there's some screws. Maybe we can pop it in this chassis. All right. Yeah, this has got all the screws missing. Good. So I don't have to take off all those screws. Yeah, this one I've been swapping out SSDs, looks like, or reballing them or something. It's a bit of a mess. A flux. But see, this has already got liquid metal on the heat sink and stuff, so let's just do that. We're going to be very careful. Let me clean this really well. We have more than enough liquid metal here, I believe. Test. What could go wrong? I'm going to try to use liquid metal because I'm not going to turn it or anything. This has still got alcohol on it. So my liquid metal's not wanting to spread. It'll dry out though. Come on, there you go. We're going to try to be really careful. Here's our board. Put a little liquid metal on there. There we go. We're going to put her straight down. We're not going to stand it up. Like so. And yes, we're going to find an APU clamp. Where did I put it? I do have some spare ones somewhere. I do have one, I know I do. I have several of them. Clamps with screws. Come on. Some of this has gotten mixed in with some of my PS4 stuff, though. Which will not work. See a bag of screws. And there's one of those sponges. Barriers. And what's in here? That's from a 1200 series. EDM20. That'll work. That will work. Oh, come on. Yeah, we're just going to be testing this. I'd kind of like to see it come on and, you know, give us a picture. And then my work is done, I think. And this all started because a little capacitor decided to short under the south bridge. Make sure all the little capacitors there for the differential pairs go into the HDMI circuit. All right, let me make a space over here on my test monitor. Get this one out of the way. This one's good. Oh, let me switch to this camera over here, if I can. I don't know if I have a scene with that full. I guess I could give it a fan, although I'm not going to run it very long. All right. What do we think? Is it going to work? Is chat still working? I can't tell. Let's go for it. She works. Oh, she's got a pin code on her. So we'll probably have to make our own login here. I don't have any antennas hooked up. Oh, it's working though. Okay. So can I back up? I'll just add a user. I'm just curious what firmware it has. User 1. Just go through the HDR stuff. Alrighty. Settings. System. Constant information. 8.0. 8.0. Well, Milton, you've got a hackable console if you choose to do so or sell it. They will sell well. So 8.0 is the firmware. But she works. She works. It is jailbreakable indeed. So, I think we're done with that. Just need to move on, and I'll get that packaged back up to send back to you, Milton. But you have a jailbreakable PS5. And she is shutting down. Oh yeah, there you are, Milton. You're there. Yep, you have a jailbreakable PS5. Do with that what you will. I've been selling them for about $450. Your mileage may vary, but I've sold several at that price. It doesn't take long to sell them, but yeah. Or you could update it and just play it, whatever you want to do. I've been streaming almost 3 hours. Almost 3 hours. I think I'm going to take a break. But that was fun. I hope you liked that. I thought it was interesting, at least. We brought one back from the dead. I'll get this thing back in the mail to you today, probably, Milton. Since I have the day off today, I've got to work some the rest of the week. So I was trying to get that knocked out today when I had the time off. But looking good. Got the capacitors replaced. Yeah, we're in good shape. Well, anyway, I want to thank everybody for coming by. Hey, Russ, Picotronics. Thanks for all the memberships and stuff. Thanks to Russ and the others who bought memberships. I appreciate the support. So I'm going to take a break, maybe play a game for a little while. I've got a PS5, and I'll show you my... I fixed up a PS5 for myself. This is mine. I like red. I put some red panels on it. Just like red. Got a red car, red motorcycle, red truck. But anyway, that's mine. Maybe I'll play something. So, well, thanks for stopping by. We will do it again soon. I've got a bunch of PS5 repairs. I've got like, I don't know, 5 or 6 on the floor here. I haven't opened the boxes on, haven't had time. So, but we'll get to those and we'll do them. Maybe we can put out some videos. Maybe we'll do some live streams. So anyway, thanks so much for stopping by, and I will see you next time. Bye-bye.